Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 4 of lesson number 1, atoms and molecules. Okay, so now as we are on to part 4, you might be very much clear with like the concept of atom, because like in this part we are going to complete all the topics with respect to atom, and we will be like further starting with adding on to molecules as well, right? And after studying molecules we have ions concept to discuss as well, right? So now as like we are almost to complete this atoms part. I want each one of you to have a very quick and a thorough revision of whatever we have discussed so far in this part, because this is very important. You revising all the concepts one by one, so that like when I am adding on to certain concepts further, you are understanding it. Because if the basics are not clear, it will and if I continue to teach you further, it won't have any you can say any aspect of like moving forward and you forgetting the things discussed before, right? So that is why before starting with that, I want each one of you to please revise whatever notes you have taken in your book. Then I will be even sharing my screen with you all, and we will be like discussing all everything about atom. Okay, so now I am going to show you one slides. Like we started this lesson by discussing about the Indian and the Greek philosophers, right? So they were always wondering about the unknown and the unseen form of the matter. So the idea of divisibility of the matter was considered over here, like it was considered in India around 500 BC. So, an Indian philosopher, Maharishi Kannad, postulated that if we go on dividing matter, that is Padartha, we shall get smaller and smaller particles, and ultimately there will be a stage which will come to an end where, like, we won't be able to divide the particles further. So he named those particles as Parmanu. Okay, then after Maharishi Kannad, the another Indian philosopher that we had was Pakuda Katyayama. So he had even like elaborated his doctrine and said that particles normally exist in a combined form, and that is how various forms of matters have been formed. Okay, so after Maharishi Kannad, Pakuda Katyayama, like around the same era, there were many different Greek philosophers named Democritus and Leucippus who have suggested that if we go on dividing the matter further, we will reach a stage like we will reach a stage when the particles obtained they cannot be divided further. Okay. I hope everyone is going through this slide. After this, we discussed about Democritus. Now, Democritus called this individual particle atom, call them as like indivisible particles. And why? What was the reason behind calling it indivisible? Because the meaning of the word atom itself was indivisible, right? So all this was based on philosophical consideration, and there was no such experimental work to validate these ideas. And like it was only till you can say 18th century. But after the end of 18th century, like till 18th century got okay. By the end of 18th century, the scientists recognized that there are like differences that exist between elements and compounds. And then that is how they became interested in finding out like how the elements are combining together and what exactly is happening when the elements combine and what is the kind of reaction that takes place, right? So Antony L. Lavoisier, they have laid the foundation of chemical sciences by establishing two important laws of chemical combination, right? And we have even discussed both the laws in detail along with proper activity, right, everyone? So before like I show you both the important laws of chemical combination, so the law of chemical combination that we have discussed, one is law of conservation of mass and the other one is law of constant proportion. Now this law of constant proportion, we also call it as law of definite proportion. Okay, so I just want each one of you to please go through it once. So I hope everyone is going through this slide as well. After this, like this is the first law that we have discussed, that is law of conservation of mass. So this law states that mass can neither be created nor be destroyed in a chemical reaction, and that is how we can state over here that the total masses of reactant is going to be equal to sum of masses of product and masses of unreacted reactants, right? So I just want every one of you to please go through it. Law of conservation of mass, whatever it states over here. After this, like this is the activity which is actually, you can say, supporting the law of conservation of mass. So I want each one of you to please go through this activity once. Now after this, like activity 3.1 on law of conservation of mass, the next law that we had was law of constant proportion, right? And we know that law of constant proportion, we also know it as law of definite proportion, right? And here we have studied two different examples. One example is of water and the another example is of ammonia. So the second law of chemical combination was stated by Proust as, in a chemical substance the elements are always present in definite proportion by mass. Okay, so this is the statement which Proust has given, but there were certain problems which were faced by the scientists, because like they were not able to give appropriate explanations on the law. So here British chemist John Dalton, he provided the basic theory about the nature of the matter, where he picked up the idea of divisibility of matter, which was just a philosophy before then. And because of the postulates that Dalton has given, it was like clear, and both the law of chemical combination was accepted. Until then it was a difficult task. Okay, so I just want you all to please go through this slide once, go through all the, you can say, examples which have been given as well. After this, we discussed on John Dalton and we stated that John Dalton was born in a poor weaver's family in 1766 in England, right? Where he has like began his career as a teacher at the age of 12, and then he became the school principal as well. And in 1793, Dalton he left for Manchester to teach like mathematics, physics, and chemistry in college, where he spent most of his life teaching and researching, and like he got the result in the year 1808, where he presented his atomic theory, which was a turning point in the study of matter. So I just want each one of you like to go through it, and then like Dalton has given six different postulates, right, which we have studied about. So I just want you all to please go through it once. I hope everyone is going through it. So here we have like the Dalton's atomic theory, which we also know it as postulates of Dalton. So I just want each one of you to please go through those postulates which have been given over here. I hope everyone is going through this. I hope everyone is going through the postulates given. After this, we discussed on what exactly is an atom, right? So I just want each one of you to please go through it once. After this, we discussed on like how big are atoms. We have discussed on the size with respect to atomic radii, right? So we know like 1 meter is equal to 10 raised to 9 nanometer, and there are many important radii of few of the examples given. So I just want each one of you to please go through it once. Just a second. After this, we discussed on like what are the modern day symbols of atom of different elements. So I want each one of you to please go through this slide as well once, because this slide is also very important, right? So, and even go through the symbols, because nowadays we don't, you can say, we don't use the symbols, right? These are the old day symbols that we had. Now modern day symbols are very different. After this, like we had some of the examples given over here to discuss. So like we have the example of hydrogen, aluminium, cobalt, and every information that has been given over here, right? So I just want each one of you to please go through it. After this, like these are the modern day symbols that we discussed, where aluminium is represented as Al, iodine is represented as I, uranium is represented as U, nitrogen is represented as N, copper is represented as Cu, then chlorine is represented as Cl, calcium is represented as Ca. So these are some of the modern day symbols that we have, right? So I just want you all to even go through it, and then we will be like completing the rest of the part that we need to discuss on atom. Okay. I hope everyone is going through it and see what they have given below. Do not bother to memorize all in one go, as and when you will study, as and when you are coming across through the elements again and again, like it will become like clear to you. Okay, so I don't want you all to put pressure of like learning this all the elements all at once. No. Okay, you will learn it slowly and steadily. So I want you all to please go through it. So we even started discussing on atomic mass, or we need to discuss it? Yeah, we started discussing about the atomic mass in the last class, and we are just left with few parts with respect to atomic mass itself, right? So before starting that, I want you all to please revise it once. I hope every one of you are going through it, because like atomic mass was again a remarkable concept by Dalton's atomic theory, where we have proposed more about the atomic mass, right? And according to him, each element had a characteristic atomic mass, which like the theory was explaining about. So this theory could explain the law of constant proportion so well that the scientists were prompted to measure the atomic mass of an atom. And since determining the mass of an individual atom, see, if we like, there are too many elements which have been known, and if we keep on determining the mass of each and every atom, okay, that is going to become a difficult task. So relative atomic masses were determined using the law of chemical combination and the compounds which were being formed. So let us take the example of compound carbon monoxide. Now we know carbon monoxide has been formed by carbon and oxygen. How exactly it has been formed? By carbon and oxygen, and it was observed experimentally that 3 gram of carbon, it combines with 4 grams of oxygen, and then only one molecule, one carbon monoxide has been formed. So in other words, we can say that carbon combines with 4 by 3 times its mass of oxygen. So atomic mass is again a concept of Dalton's atomic theory, and he was the one who has proposed this mass. Okay, so I just want you all to please go through it once. So I hope everyone is going through this slide. I hope everyone is like going through it, and whatever you points you feel are important, make sure you're writing them in your book. Okay? After this, now see. Suppose we define the atomic mass unit. like we have already studied this, right? AMU. So now instead of using this unit as like atomic mass unit, we just use the term as unified mass, right? And always remember that this unified mass is going to be equal to mass of one carbon atom. And then we could go on, like we would assign carbon an atomic mass of 1.0 U, and oxygen an atomic mass of 1.33. Okay, so I just want you all to please go through it. I hope everyone is going through it because here we have most important questions given on carbon 12. So I just want each one of you to please go through it once as well. After this, now see. Imagine a fruit seller selling fruits without any standard weight with him. So he is not having any weighing balance or anything, and he's just like selling a standard any fruit with a standard weight with it. Okay, so he takes a watermelon and says this has a mass equal to 12 units. What does it say? What does he says? That this has a mass equal to 12 units. It means 12 watermelon units or 12 fruit mass units. So now what he will do, he will take 12 pieces, equal pieces of watermelon, and find the mass of each fruit he is selling, and that is going to be relative to the mass of one piece of watermelon. It means, according to him, 12 pieces, equal pieces of watermelon is equal to one big watermelon that he's selling. So now he sells his fruit by relative fruit mass unit. So that A, atomic mass unit, becomes over your fruit mass unit. So I hope you're getting that, like what exactly unified mass is, right? Because if I give you a whole watermelon, or if I give you 12 pieces of watermelon, that is going to be the same, that they are going to be equal. So when we are just cutting it and selling it in equal parts, we like know that unit as atomic mass unit, and because here we are doing it with respect to a fruit, So that becomes fruit mass unit. Okay, so if you can see in figure 3.4, we have a whole watermelon. In the second picture we have 12 pieces of watermelon. The third picture we have 1 by 12 pieces of watermelon. Like in the third picture that we have is one piece of watermelon, and all the 12 pieces of watermelon are going to be of the same size. And when all those 12 pieces of watermelon, they have been combined together, that is how we get a whole watermelon together. Okay, and the D picture, it shows us how the fruit seller can weigh the fruit using the pieces of watermelon. So now because he know the weight of one piece of watermelon, the fruit seller can use that piece of watermelon for weighing the fruits, for weighing the other fruits, because he know what is the actual and the exact weight of one piece of watermelon, right? So similarly, the relative atomic mass of the atom of an element is defined as average mass of the atom as compared to 1 by 12 the mass of one carbon 12 atom. Okay, so I just want each one of you to please go through this slide once, and you can even explain that in your own words. Okay. I hope everyone is writing it in your book. I hope everyone has written this. Now here we have the atomic masses of few elements which have been given, and like this much elements I want you all to please know, like the atomic mass and the elements. Okay, so when it comes to hydrogen, the atomic mass of hydrogen is 1. For carbon it's 12, for nitrogen it's 14, oxygen it's 16, sodium atomic mass is 23, then for magnesium the atomic mass is 24, for sulfur it is 32, for chlorine it's 35.5, and lastly for calcium it's going to be 40. Okay, so I just want each one of you to please go through it once. I hope you all are writing some of the like the atomic mass of this element. I hope everyone is writing the atomic mass of the elements. After this, like now the question is, how do atoms exist exactly, right? So see, atoms of most elements are not able to exist independently. So atoms of like most of the elements, they are not going to like exist independently. Atoms are going to form molecules and ions. What are they going to form? They're going to form molecules and ions, and this molecules or ions, they are going to aggregate in large number so that they can form the matter that we can see, feel, or touch. Okay, so the atoms are not going to exist independently. They are going to form either molecule or they will form ions, and this molecules and ions, they will further aggregate. They are going to aggregate in large number, and that is how these molecules and ions are further going to make the matter that we can see, feel, or touch, or everything around us. Okay. So I hope you all are writing the statement that atoms, they are not going to like exist independently. They are going to combine with either molecule or ions, and those molecules and ions, they form, you can say, the matter around us. Whatever we can see around us is all because of the formation of molecules and ions. Okay. After this, now what is a molecule? So we will do like a basic introduction to what exactly molecules are. Okay, and then we will discuss like molecules of elements in the next class. Okay, so see, what are molecules? A molecule in journal is a group of two or more atoms that are chemically bonded together, and that is tightly held together by attractive forces. Okay, so atom, as we just discussed, they are going to exist independently, right? So these atoms, when they are existing independently, like most of the elements cannot exist independently. So they're going to come together and they're going to form either a molecule or they will form ion, right? And these molecules and ions, they are good. They are going to further make up the matter around us, and matter is something that we can feel, touch, or see, right? So a molecule is in general a group of two or more atoms. Now this two or more atoms, they are chemically bonded together, and because they are chemically bonded together, they will be held together by strong attractive forces in between. Both the atoms will have attractive forces in between. So a molecule can be defined as smallest particle of an element or a compound. Now molecules are smallest particle of any element or compound, because we know element will be like, see, when atoms, they make up the element, elements, they make up the molecule. Okay, so this element or a compound, they are going to be capable of an independent existence, whereas atom, they do not have that independent existence. Okay, so but this molecules, they are capable of independent existence and show all the properties of that substance. Okay, so atoms of same element or of different element. Now though, if the atoms, like we know that there will be two or more different elements or compounds joining together, so like those elements can be same, like carbon, 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 they are like all bonded together through a strong attractive force. So they can be either the same element or they can be different elements that can join together and they can form a molecule. Getting it? So atoms can be of same element or they can be of different elements, but they will be joined together, and when they will be joined together, they are going to form molecule. So we have certain examples over here. Now when it comes to oxygen, oxygen is formed by the same elements. There are two oxygen which are coming together, right? Then methane has carbon and hydrogen all together. I hope you all are writing the important points on molecule and you are even taking a note of example. So after this, like methane, we have caffeine and DNA as other examples. So I just want each one of you to please go through it. I hope everyone has written all the points with respect to molecules. Okay, now and you know how exactly like molecules and ions are been formed. Okay, so now in the next class, we are going to study about molecules of elements. Like what exactly are the molecules of elements? So we have like argon, helium. They are all made up of only one atom of the element, right? So, but they are non-metal. So we will be like discussing on the like we will be discussing about the molecules of elements with respect to metals and non-metals as well, and we will even discuss on what is atomicity, right? So the number of atoms constituting a molecule, we know that as atomicity, as its atomicity, right? So we'll discuss on molecules of elements, and here, as I was discussing about atomicity, we have different elements like having different number of atoms. So, like here we have examples of argon and helium. Now, argon and helium are monoatomic because they have only one atom in them, right? Oxygen is written as O2, hydrogen is written as H2, nitrogen is written as N2, chlorine is written as Cl2, right? So, they are all diatomic. What are they? They are all diatomic. And then we have like phosphorus, which is tetraatomic. Why tetraatomic? Because phosphorus has four different atoms altogether. And after this phosphorus, we have sulfur, which is polyatomic, because sulfur have more than four atoms in it. So we don't go it like penta, hexa, septa, octa. No, we can directly write it as polyatomic, and this is how the atomicity of the elements are been known and they have been written. Okay, after studying the atomicity of some elements, we are going to discuss on molecules of compounds. Okay, and under this molecules of compound, we will have different compounds like water, ammonia, carbon dioxide, and they will be given in different ratio by mass. So we know that water is made up of hydrogen and oxygen, right? And the ratio by mass of hydrogen and oxygen is 1 is to 8, because hydrogen is present in only like 1 gram and oxygen is present in 8 grams. That is how we get 9 grams of water formation which takes place. If you remember, this is what like this is the same thing that we have discussed. If you remember, we have discussed on the example of water and ammonia before as well, right? So here you can say that carbon dioxide is an added thing, and we know that carbon dioxide is made from carbon and oxygen, right? So carbon will be in the ratio as 3 and oxygen in the ratio as 8. So that is how when this carbon and oxygen they are combining in a specific ratio, they are like they are forming a specific compound called as carbon dioxide. I hope you all are getting like at least a bit small idea on compounds and how exactly which are the different elements which combine and what is the ratio in which they need to combine, and that is how they have been formed, right? So this is also a basic journal, you can say information which has been given, which we will be discussing in detail. After that we will be discussing on activity 3.2. We will be having different elements along with ratio by mass, their atomic mass. Then we have atomic mass divide by mass ratio divided by atomic mass unit. Then we have the simplest ratio which has been given. Okay, so we will be discussing on all of that through the activity 3.2. And after that we will be discussing on like we will complete with molecule over here, and we will start our discussion with respect to like what exactly is an ion. So we will be discussing on like ions are something which have like certain amount of charged, and mostly all the charged species around us we know them as ion. And always remember that that an ion can either have a positive charge or they can have a negative charge, but they are going to have certain charges with them. And the positively charged ions, we know them as cation, and the negatively charged ions, we know them as anions. So this is how like you can know about cations and anions in detail. Okay, after that we have discussed on like we have some of the ionic compounds which have been given over here, but along with that we have the constituting element, and the different ionic compounds which have been given over here are calcium oxide, then we have magnesium sulfide, and lastly we have sodium chloride. These are the different ionic compounds, and like the constituting elements and the ratio by mass have been given. So when it comes to calcium oxide, they have been formed by calcium and oxygen, right? And the combining ratio of calcium and oxygen is going to be in ratio as 5 is to 2, right? It means when 5 grams of calcium combines with 2 grams of oxygen, that is how calcium oxide has been formed. Okay, After this, we will be discussing on like how to write the chemical formulae of different elements, molecules, and ion in detail. Then after that, we will be discussing on the valencies of some common ions through this table. So we have the name and symbols of some ions which have been given. How do we exactly represent them? Like for hydrogen, they have like denoted it as H plus. Hydride has been denoted as H minus. Then we have copper has been denoted as Cu plus. So that is how we have different symbols and names which have been used for representing the ions. Then we will be discussing on the rules to write the chemical formula, but because there are certain rules which we need to follow to come up with whenever we have to write any of the chemical formula of any compound, molecule, or anything, we have to do it. Okay. After this, we'll like study on how to write the formulae of some of the simple compound in detail. We'll discuss about that as well, like how can we write the form, like we have like in detail how to write the formula of some simple compounds. We'll discuss that. Then we will be even discussing on molecular mass and mole concept in detail through different examples. Okay. Then we have like formula unit mass to discuss in detail, which we will be again discussing. And then we have mole concept to discuss like what exactly the mole is, and we will be discussing it through different you can say examples. And before studying with the examples, we will be even discussing the relationship that exists between mole, Avogadro number, and mass. So I just want each one of you to please go through it. After this relationship between mole, Avogadro's number, and mass, we have like 3 4 examples which we will be discussing about. Okay, so these are the different examples we will discuss on, and after that we are going to like discuss the summary discussion on the whole lesson. Okay, so after doing the summary discussion, we have some of the exercise questions to discuss as well. So I just want each one of you to please go through it once. I hope every one of you are going through the question which are been shown on the screen. So like we have like altogether I guess 9 to 10 questions which we will be discussing on. So we have like one of the question as polyatomic ions and give examples of them. So we'll be discussing on that as well. Then we'll be discussing on the chemical formula of the following, where it includes many different names: magnesium chloride, calcium oxide, copper nitrate, aluminium chloride, calcium carbonate. These are some of the names that we need to write the chemical formula for. Then the next question that we have is we need to write the names of the elements which are present in the following compound. So it includes quicklime, hydrogen bromide, baking powder, potassium sulfate. These are the different elements for which we need to write the names. Okay. Then we will be discussing on the molecular mass of the following substances. So it includes ethine, sulfur molecule, phosphorus molecule, and hydrochloric acid to discuss in detail. And then we have the seventh question for which you need to write the answer for. So I just want you all to please go through it as well once. So here we have some of the numerical kind of thing where we need to convert this into mole. So 12 gram of oxygen gas, then 20 grams of water, 22 grams of carbon dioxide. So this is how, after discussing 11 questions, we are going to end up with the lesson atoms and molecules. And I hope whatever we discussed in this part of the lesson, we have completed the atoms part and we have initiated the studying about molecules as well. So I just hope each one of you have understood the concepts till whatever we have discussed so far. Now whatever part has been left, I'm going to continue that in the next part. But before that, I want to tell you all that keep on revising whatever we have started so far. Okay. So the rest of the part for the lesson I will be continuing in the next part. Thank you everyone.